Hi everyone, welcome to Preparing for Math League 1.4 and welcome to Prime Time. So this video will prepare you for the Math League competition for 4th and 5th graders, but make sure to check out previous episodes before watching this one. Let's blast off. First, let's go through some definitions. So prime numbers are numbers that have only two factors, one in itself. For example, 5, 7, and 13 are prime numbers because they only have two factors, which are 1 and itself. The only factors of 5 are 1 and 5. On the other hand, composite numbers are any number that's not a prime. So they are numbers that have more than two factors. Some example of composite numbers are 4, 15, and 28. For example, 4 has a factor of 1, 2, and 4. 15 you can divide by 5 and 3. And 28 is also similar. You can divide it by 14, 7, 4, and 2. So they all have more than two factors. Also, a hint, all even numbers are composite because they are all divisible by 2. Okay, now that we know these definitions, let's do some problems. Okay, so the challenge here is to find the prime. Which of the following numbers is prime? 8, 15, 21, or 23? So let's just go through the answer choices. For an answer choice of A, which is 8, 8 is divisible by 2 and 4. So it has more than two factors and it is not prime. Let's check 15. 15 is divisible by 5 and 3, which means that it is also not prime because it has more than two factors. For an answer choice of 21, it is also not prime because it is divisible by 3 and 7. And now let's just check the last answer choice. So 23 is divisible by 1 and 23, but not any other factors. And remember, a prime number means that it is only divisible by 1 in itself. So that means that 23 is the prime number. And that's our answer. Yay! Now let's try to find the first 10 primes. So we have a few written out here and we need to fill in the blanks. We have 2, 3, blank, 7, 11, 13, 17, blank, 23, and blank. So let's look at the first blank. We know that it has to be between 3 and 7, and the options are 4, 5, and 6. Out of these, 4 and 6 are even, which means that they are not prime because they have a factor of 2 and therefore cannot be prime. That leaves us with 5, so there goes 5. And that's prime because it is only divisible by 1 and 5. Now let's look at the next blank. It is between 17 and 23, so it has to be 18, 19, 20, 21, or 22. Let's get rid of the evens because all evens are not prime. Now it's between 19 and 21. Let's think if they have any factors. 21 can be divided by 3 and 7 besides 21 in itself. So that means that 21 is not prime. Therefore, our prime here is 19. That's our answer there. So now let's do the last blank. Let's count only the odd numbers from 23. Hint, we don't need to count the even numbers because we know that they are not prime. So 25 is divisible by 5, so it is not prime. 27 is divisible by 3, so it is not prime. And 29 doesn't seem to be divisible by anything other than 1 in itself. So that's our answer. Now let's do a problem that's just a tad bit harder. When each of the following numbers is divided by 6, only one gives a remainder that is a prime number. Which one is it? A, 436, B, 442, C, 453, D, 468. So let's first move it to the next side so that we have more space. And the question wants us to divide the numbers by 6 and look at the remainders for a prime number. So let's do this and start off by going through the answer choices. For answer choice A, 436 divided by 6 is 72 with a remainder of 4. By the way, the capital R here represents remainder. 4 is not a prime number because you can also divide it by 2. So let's check the next answer choice. B is 442. 442 divided by 6 is 73 with a remainder of 4. And again, 4 is not prime. So let's go to the next choice. For C, 453. 453 divided by 6 is 72 with a remainder of 3. And 3 is a prime number because it is only divisible by 1 in itself, which is 3. So our answer choice is 453. Great work, and let's do one last problem together. So Karen here on the bottom left wrote down every whole number less than 30 that is one more than a prime. How many of these are multiples of 3? A1, B2, C3, or D4? Whoa. Okay, this problem just said a whole bunch of words, and we need to break it down a bit. Let's start with writing all of the prime numbers less than 30. If you remember from before, it's 2, 3, 5, 7, 11, 13, 17, 19, and 23. And a special case is 29, but we'll talk more about that later. However, we can keep it there for now. Now the question says one more than a prime number. So we need to add one more to each of these primes. This becomes 3, 4, 6, 8, 12, 14, 18, 20, 24, and 30. And notice how we just added 1 to each of the numbers in the list. However, remember that Karen only wrote down every whole number less than 30. 30 is not less than 30, so we take it out of this list. Now we count how many of these are multiples of 3. Multiples of 3 are numbers that are divisible by 3. So we have 3, 6, 12, 18, and 24. And that is 1, 2, 3, 4, 5 multiples of 3. And 5 is our answer. Karen says thanks and great work, everybody. Now we have a few problems for you to try. Which of these 3-digit numbers is a prime number? A, 142, B, 145, C, 147, or D, 149. You have 30 seconds here, but feel free to pause for the video for more time. And the answer is D, 149. Did you get it? And here's the solution. All of the other numbers except for 149 are divisible by something other than 1 in itself. So that makes 149 the only prime. Okay, next question. What is the smallest 2-digit odd number that can be written as the sum of 2 and a prime number? A, 11, B, 15, C, 17, and D, 20. You have 45 seconds. And the answer here is B15. Out of the answer choices, if we add 2 and another number, only 15 is 2 plus a prime number, which is 13. So our answer is B15. And we're on to the last one. You guys are doing great. When each of the following numbers is divided by 5, only one gives a remainder that is a prime number. Which one is it? A, 250, B, 301, C, 317, and D, 344. You have 45 seconds. And the answer is C, 317. So this problem is like the problem we did together earlier, and we just divided all of the answer choices by 5 and looked at the remainders, which remember are marked by the capital R. So here out of 0, 1, 2, and 4, 2 is the prime number. So when 317 is divided by 5, it has a prime remainder, and that's our answer. Okay, great work everybody, and thank you so much for watching, and congratulations on completing the video. Please go to thenumberplayground.com to check out more. See you next time. Bye!